Please give a warm welcome to Dr. Krishnan.
All right. Thank you, Navin. So good morning, Seattle. Good morning, everyone. Thank you for coming together today. So as you can see that I work at Hitachi and I had a small team of people, geographically distributed. We do a lot of AI ML stuff. So this is one of the projects what we have been doing for the last couple of months. Just going to share some of the results what we have got. And let's keep the questions towards the end. I have a couple of slides to go through. And as Navin introduced the Google Developer Experts this morning, I happen to be GDE for Google Cloud as well. I've had the privilege of being that for the last 5 years. So if any of you want to know how to become one, feel free to talk to me during lunchtime. Having said that, let me just get going into the talk right away and say, most of the time we have some agenda, what we are going to do, and then show the demo later on. But I'm going to flip this around and say, hey, what is that we actually built that is very important to you guys, or the results thereafter, right? So in this particular problem, there was an opportunity that Hitachi was working on, or let's say my company was working on, where we have to identify the faces, we have to detect the faces, we have to track the people, and we have to redact people who are not person of interest, okay? So we actually built a solution. We call it as a solution because we consumed quite a bit of open source software. We did our own innovation on top of that. And what you're going to be seeing in here is the net result that actually comes out of it. So let's start with the actual demo itself in here, right? So I want you to watch the person number 10. We like the person, it's as if magically she knows that we are actually capturing the video. And of course, we did not capture the video. It was some video from the internet, okay? So this is what you're going to be seeing how we actually built a solution that actually created this video in terms of not only tracking one person, but tracking multiple people and also redacting people who need not be redacted or who needs to be left unredacted kind of thing. So okay? Okay, thank you. All right, so now let's get into the agenda in here. Basically, I'm going to be defining which category of people, which category of market actually requires this problem to be solved. What is the solution approach? I'm going to walk you gently into introducing a flow chart, not much on mathematics side of things, but more into logically, how would this problem be solved? What is the takeaway that you can take from there? Just identify 4 key features, and of course, few more demos. Not the first demo, but several more demos that is coming thing. And a sneak peek into, there's an error, it's not the peak, it's a PEK. We'll fix it later on. But then sneak peek on what are the other projects, what we are doing. So first thing, where does this whole opportunity exist, right? So it's in law enforcement area. So wherein there are a lot of people uploading videos on the internet, whether it's from Ring video camera, Ring Bell video camera, or your Nest video camera. I'm sorry, this is Google, right? So we talk about Nest video camera. And then when these videos are going to be presented in front of a judge, in front of a district attorney in the US, what happens is you need to leave the people who are person of interest intact, but everybody else should be redacted, right? Legal requirement, privacy reasons kind of thing. So now, that's the opportunity that we are currently working on, and this is take it like version 1 of the result there. So now, some of the things that needs to be redacted is face, number plate, street signs, all of them. And again, face makes sense from a privacy. It just happens that number plate, non-important number plate should be detected and redacted. And of course, street signs, if you show them, kind of having a negative impact on the property value in that area. So street signs also should be redacted. Then the question comes in, why do we need a solution for it? Why can't we do it manually? Yes, you can do manually with an old videos wherein 30 frames per second kind of thing. But with 4K videos with 60 frames per second, 120 frames per second, you can't really put a person to actually do it. At the same time, there is so much amount of video that is being uploaded to many of these portals, so we need an automated method to do this whole work. The third one is that many of the CCTV camera these days are not stationary. They're actually panning back and forth. So when you have panning cameras back and forth, the challenge becomes that, hey, I saw Krishnan in this particular frame. Is this the same person who I now see a different side profile when the camera actually pans together? So we need a method to actually track people who are non-stationary. Either the camera is not stationary or the person is not stationary, right? So this is required. That's the third challenge that we kind of undertook and solved in this whole project. And the last one is, yes, there's a lot of open source libraries. As I said, Here it's more about building a solution that comprises of, let's say, a working solution. We did a little bit of coding, but we also consumed quite a bit of open source software. That means each of the software by itself is not a perfect fit for the problem. They are solving part of the problem, but not the entire problem. So we amalgamated multiple things, and that's where you see no single open source library on the internet that we are familiar with is able to solve this problem, right? So we did a lot of scouting on the internet, and then we started doing our own work. So now, what's the solution, right? The first thing is we call our solution iRedact. No link to any Cupertino company, to just make it very clear. This has nothing to do with iPhone or anything else. I just call it iRedact, and then it kind of comprises of framework libraries. There is a CLI that you can use. So if there is an opportunity to do a workshop, I'll be happy to show this whole, everything is Python. Python is the primary programming language in my group. CLI, GUI, and also integrates with the web app. The web app purpose is primarily to manage the video, right? Somebody uploads a video to a portal, and here is a law enforcement officer who needs to redact or not redact. Those are the things. And iRedact itself comprises of 3 components, which is face, number plate, and also street signs. This talk, we are going to talk only about the face. There is a sneak peek about number plate and street signs. Okay, and I'm talking a little bit fast, but just bear with me. I just want to cover a couple of slides so that there is some value at the end of the day, at the end of the session for everyone who came today. All right. Now, iRedact face. Here is the algorithm that eventually that worked for us. So first thing is, here comes a big video. It could be 4K video. It could be full HD video. We first have to chop it into frames. Okay, very logical step. Everyone knows about it. But now there are multiple methods that actually works it, and we tried a couple of methods, and we ended up with one method that was OpenCV. I have more details later on. We end up into chopping into frames. Now, once we have this, frames, everything there, now we need to detect how many people are there in the particular frame. Let's say there is a security camera running in here. The camera captures video of this room. There are a lot of people in this room, right? So we need to detect how many faces, how many human faces are there in this particular video. Now, as I said, no single open source library was able to detect everything, primarily because this particular, some of these libraries detect large faces. Some of them are good at right profile faces, left profile faces, partial faces. These are all challenging. So we ended up, cumulating together or amalgamating couple of libraries together, and a method through which to say if there is a bounding boxes for 2 people or 2 bounding boxes in a video, is it referred to the same person or referred to a different person, right? So we'll have more details coming together. Now, once we have all those faces there, we need to say, well, there are 2 faces. Is these 2 faces 2 different persons? How do we know, right? So essentially, for people who are in OpenCV world or who are in video processing, you have something called facial embedding. But for everybody else, it just means that we create something like an equivalent of a fingerprint for the faces, right? So it's just called as facial embedding. Again, using an open source library from Google called as FaceNet, we slap on top of that, of the frames, the faces detected, to create a unique fingerprint or face print, if you want to say it so, with all the people detected in the particular frame. After that, now the video is being moving. Now the video is moving. Then we need to track to say, hey, is this person moving, right? One person, say person A, was an X coordinate X and Y. Now the person is going to move to coordinate, let's say X plus 1 and Y minus 1. Is this the same person? How do we know that? We repeat the same process by extracting the faces, extracting generating the thumbprints or face prints, and then combining them to see that, hey, is it within the same distance vector, within a threshold to see, is this the same person or a different person? So that's what you see in terms of deep sort tracking. I have more details in a second. And finally, there is a very unique problem that when a security camera is panning from left to right, let's say I'm stationary on one side of the room and I'm talking with my friend, but the camera just went away and the camera is now coming back. Because the camera went away, I went out of frame. Now there is a real problem that when I come back, I could be given a different ID. Now remember, all the IDs what you saw in the first video, the demo video, these are all system generated, right? The first phase I detect number 1, second phase I go number 2. I do not assign it. So when you come back in here, now Krishnan got 10 in one of the video, now Krishnan got 20 in another video. Is 10 and the 20 the same person or is a different person? So that's what we solve using the clustering. Now we put together all the solution together so that we put together all the steps rather, create a solution so that this solution is now capable of processing videos, and it's going to be automatically generating, what we call it as a checkpoint file. More details soon. With that, we can now give it to a law enforcement officer who can select some of the frames to say, track this person, and then redact every other person. Okay, make sense? All right. Sorry. Thank you for keeping with my pace of talk. I'm from Virginia, by the way. I'm still got up early in the morning with the time zone. All right. So now, so first thing, extract frames from video. That's OpenCV. That's the method that actually worked. Face detection networks, as I said, there is no single network that actually worked with everybody, with every face, every video we tested. We ended up with selecting 3 different methods. There was no threshold for 3 or 4. We started, experimenting with a lot of libraries. And as there was an overlap between other libraries and one library was performing better, we started dropping, and we eventually ended up with 3 libraries. The names are coming up in the next slide. Then now each of the libraries is going to be detecting, let's say it's detecting me. One is going to draw maybe a rectangular box. Another one is going to draw similar bounding boxes, maybe not exactly overlapping. Now with 2 of these overlapping boxes, we need to see, is this 2 different people or is it the same person, right? So we used a non-max suppression method for that. Then we generate the facial embeddings that's using the face net, as I mentioned a little bit earlier. Then we introduce deep sort to actually track the people, and finally we cluster it with DB scan clustering. Okay? Now with all these things done, this we call it as pre-processing, right? Because we are also not a pure academic group. We are an industrial group wherein we need to take the solution and need to be able to scale it, maybe not Google scale, but let's say scale it so that we are able to do a lot of processing. So we create in step number 7 checkpoint file, and the checkpoint file is basically a JSON object that just says, here is a tracking ID for each unique face. That face appeared in this particular frame, and here is the bounding boxes for that particular person. So we create all these things. So through the pipeline, we just simply call it as an iRedact pipeline. In comes a video, out comes a JSON file. This is a single-time processing, and we just literally created a full, let's say, X-ray of every person in that particular video. Once this is done, we then built basically a simple Python UI for LEO as law enforcement officer to select 1 or more faces. So now comes the challenge that initially when we're doing the project, the requirement was, I'm going to select only 1 person and everybody else must be redacted. This requirement kind of changed and said, what if 2 people in the suspect in the video are working together? I need to be tracking those 2 people, right? But now leave everything else. So we have to kind of expand it to say, it doesn't matter whether it's 1 person or any number of person, you will now be able to track. So even if a group activity that the LEO wants to track, we are now able to do that. All right? So it's a Python UI, then basically give the raw video, give the JSON file with this small little UI tool, and then out comes a redacted video. And depending on whether we have access to CPU, GPU, maybe TPU one day, we'll be able to do faster. Right now we have tested with GPU and also CPUs. Then last one is iRedact was integrated with a custom web app that was just to manage videos, right? That's pretty much uploading, managing, tagging, user authentication, all those things. So now with that said, I want to go with 4 key features. Maybe it's time to a little bit slow down and give you slightly more details. The first thing, as I said, the challenge is detecting faces in wild is still a challenge, irrespective of the recent process. And again, there face orientation, ratio, size, background, everything can affect. Now, the net result is almost impossible for a single neural network or single network to identify all faces. Our approach was to run multiple networks in parallel, amalgamate the results, and then these are the 3 networks. We saw the name earlier on. Here is the expansion of the name. These are all academic papers behind it. There are also libraries behind it. So we, the approach what we took in building the solution is to use pre-trained networks or pre-trained models, and then we did a little bit of transfer learning in order to get the final result from there. That's key feature number 1. Key feature number 2, facial embedding generation. This is again using Google's FaceNet. Essentially for every bounding box for a face that we detected, we took it, we ran it through the FaceNet. That gave us a 128-byte vector that we stored it. That kind of became as not exactly a tracking ID, but then unique, let's say, facial fingerprint for that particular person. Now, key feature number 3, now we are going to be tracking people across the frames. So we were hunting for some methods for it, academic solutions. We ended up discovering there is something called SORT, which is simple online and real-time tracking. But then there was another paper which was Deep Sort, which built on SORT. So we first started off with SORT. Then we looked at Deep Sort, and we integrated Deep Sort with facial embedding. So our solution, the uniqueness of the solution is that first, we took the images. We did not stick with one particular pre-trained model. We took multiple pre-trained models. We found a method of amalgamating the results together. Then we introduced facial embedding on top of it. And finally, we introduced Deep Sort to actually track the person as they go through this whole solution. Okay? So this is the third key feature. Now, the fourth one is basically clustering. And again, clustering is required when you have more than when you have the person go out of the frame and then come back into the frame. All right. So this is the features. So with that, let's say the theoretical section of it is a little bit done. Now I'm going to be talking about the results. Right. Of course, you saw one of the results, but that didn't include the redaction part of it. So now I'm going to show a couple of results. And for this, whenever we do any work in my group, we want to compare against the best. Okay. And it just happened that we were comparing with YouTube Studio, and then we got this opportunity to talk into Google ML Summit. So every one of this use cases video what we had, we took it, we uploaded into Google's YouTube Studio. The YouTube Studio has a capability to redact faces. Okay, so if you're not familiar with it, go check out. It has a capability. It has a feature there. Let's see how iRedact compared. So I'm going to be talking about 3 demo videos kind of thing. The first demo video, lot of people, lot of different faces. The camera is going to be panning back and forth, right? The small faces, big faces, partial faces. This is the first demo. This is the first rather testing video what we took. So here, this just shows a couple of screenshots between where iRedact performed better compared to YouTube. So in this case, the video what you're seeing is President Trump's inauguration video, I think 2017 January, right? And then we just took the video that was available from whitehouse.gov, and then we ran it to a solution. You can see on the left that we were able to detect and redact more faces, but then the YouTube version was not able to detect small faces, right? And I have the video playing in a minute, but just to show where the differences are. And in this case, we were tracking First Lady Melania Trump to see, leave out Melania Trump and then, detect every other face that is detectable and also redact those particular faces. So now, coming back to here, again here, the circles show the difference that in iRedact, we were able to detect, probably the Secret Service people walking behind the president. We were able to detect and redact, but then YouTube was not, able to detect it. Again, we are not saying we are perfectly, better than YouTube. We have examples where YouTube, was slightly better. Let's take a look at the particular video here. So as I said, we were tracking Melania Trump here. So every other person, human face, we were able to detect. Then we were able to track, and then we were able to, redact as well, right? So now, let's go to the next one. I don't want to play YouTube video, but it's just present in here to show wherever the critical points that I actually missed. Now, interestingly, when I did the first demo, in an internal presentation, one of the person came and said, are you a Republican, right? I'm like, well, I'm a scientist. In all my projects, I take the role of a principal research scientist. Scientist and Republican seems to be the same number of characters. So I said, we have to dispel this and say that we are not going to be we are not going to be seen like this. So the next video, what I actually took, what happened to be just President Obama's video. It's one of the national security briefings, and here the challenge and the opportunity is that Obama was giving a talk. There are only very few people. The faces are not moving a lot. But the glass, what you see in front of President Obama, actually has a reflection of the face. Probably the video camera, the person of video who's shooting the video and kind of thing. So that kind of interfered with it. Again, here to show that in this case, it's an example where YouTube, in exactly one instance, was able to detect a better face compared to we could not we tried multiple times, but we could not detect that particular partial face. So that's going to be in I think it's 18th second, so let me just play with it. So it's going to be this particular person. When she bends down to take something, we will be missing that face. So again, it's 18th second. Yeah. So you can just see that, it's a very, so it's not even a full face. It's just, probably half of the face, and then, we'll take it from there, right? So, okay. So this is about this one. So now, this is YouTube, which does a very good job. They kind of, track all the faces. They kind of track all the faces, and then they're also redacting it. You will see the same person. They do not miss the face. So if there is somebody from YouTube Studio, happy to exchange notes later on, right? Right, so yeah, this is on the 18th second, the same video, the person will come down. They still maintain the tracking, and they are able to show that. Now, the point here is it's very important to know that in the law enforcement area, privacy is a very important thing. Even if you miss a single face, your video or video evidence may not be accepted in a court, and that's where we take very good care that we need to be redacting all these faces. Now, demo 3. Right? Whether we are Republican or Democrats, it doesn't matter. Most of the time, people in all the countries, what do we care about? Shopping, right? So we took a Black Friday video, very noisy environments. Here, we are not perfect, okay? Neither is YouTube. But then we did a much better job compared to YouTube that here is an extremely noisy environment with a lot of people going back and forth. And then there's a lot of racks in there. And we did not do a good job, but at the same time, this is not an evidence video. We just took it as a challenge. We ran it to the solution. You would see that we did miss a few faces here and there. We are tracking this particular person there, but then most of the other faces we were able to detect. Yes, a little bit faces on those boxes as well, right? So this is to show a third video that we took in here, right? So again, this whole thing, the primary thing what I want to share what I wanted to share here is about a solution that we painstakingly put together to show what's possible with open source libraries and some little bit innovation on top of that. So now this kind of brings the end to my presentation, what I want to talk about in here, but I want to give you a sneak peek. So first thing is iRedact. I told you about, this talk is about face detection, redaction kind of thing. Here is number plate, street sign, and we also have a very interesting project that we are doing defect detection on utility pipes. Just going to take a couple of more slides to show that. So iRedact number plate. Here is one detecting the number plate, and then with high confidence what's the number plate. But here is a video of the number plates being redacted as well. You would see that here we processed a live video, and the live we need to detect any number of number plates, and we need to redact it, right? And this just goes on for a second, and then you will see that the vehicle will accelerate, slow down. But this is still work in progress. It's not a fully baked solution. So you would see that in very few instances we do miss the number plates from certain vehicles in there. All right, so talking about street sign is actually an interesting problem for us because, again, as I said, if there is going to be an evidence video from a CCTV that shows, let's say, any unfortunate incident in the neighborhood, if you don't redact the street signs, the property value is going to go down, and that gets into lawsuits and stuff like that. So we'll need to detect street signs. We need to be redacting it. So here, what you see is a couple of street signs. On the first column, you have just the street signs on the wall. There's a street sign directly, independent of the wall. We are able to detect the street signs, and then we are able to redact it. So you might be wondering at this state, hey, you're just doing OCR, and then you're doing bounding boxes, and then you're trying to redacting it. Actually, the solution is not that simple because here is a street sign from a video. You can see from the result below that yes, we do OCR, we do it says car wash, but we know that that's not a street sign, right? So in this case, we don't need to redact it. So it's not just OCR. There is some library references. What we do to say, is this an address, right? Or is this actually some name board, lying down somewhere? Okay. So that's iRedact. And just one last video on this one, not exact video, just a frame in here. You would see that this is a utility pipe running underground in the US in one of the counties. And right now the process is that They send a rover down it, and somebody records the video, painstakingly looks at all those things, and modifies, registers all the crack. One is the picture on the left just shows that at frame time, let's say some time, we detect a crack on the top. Next frame, we are actually expanding the crack. This is again using deep neural networks. This is a very big utility in here because the pipes in the US are getting old, and we need a more efficient method of doing this whole stuff, right? So this is again an ongoing project. As I said, I'm not a Superman. I've only had a team. I'm a principal research scientist. We go in packs, whether it is comprising of data scientist, data science engineer, and data engineer. Just to give not just to give a recognition to my team, and of course, my extended team. Naveen talked about inclusion, diversity. We are taking conscious efforts, me and Hitachi in general, to say, and you can see whatever your definition of diversity is. This is my new team right now, interns. We are hoping to hire them from January 2020. Again, they also contributed to iRedact street sign and number plate, and the previous slide was about the face. All right, so that really brings to the last slide. If you have anything private, please use my Gmail. I live in Washington, D.C. metro area, 1 mile from Washington Dulles Airport. If you have anything official to talk with, that's my official email address. Happy to give you name cards as well later on. Okay, with that said, I think I'm right on time. Floor is open to questions.